Anyway, I'm very happy to be here today. I'm just going to give a sort of update on where we are with NASA, SMD, PSD particularly at the moment. So I will jump right in. And if you could go to the next slide, please. Excuse me. Okay, so this is the current leadership team. So it probably looks a little bit different from the last time you had someone from PSD there. So I think it was probably Gina this time last year. So Gina DiBraccio served in the PSD director role for 6 months. She stood down in November and Charles Webb took over. So they were both acting. Charles took over for a few months until I came on board in April. So we've had a lot of sort of moving chairs up here at headquarters, but I'm hoping to be here for a while. Charles is now in the deputy role, so I'm really thrilled to have him, and both, thanks to him and Gina for the work that they did in the division. This is just the rest of the current leadership team and most of the ones that are relevant to this group. So Shannon Fitzpatrick is our Associate Director for Flight Programs. Kathleen van der Kayden is our PSD Director of Research Programs. I think she was acting this time last year. She's now permanently in the position. Tiffany Morgan is our Mars Exploration Program Director, and Lindsay Hayes is the Senior Scientist for Mars. Kelly Fast is our Acting Planetary Defence Officer. David Grinspoon is our Senior Scientist for Astrobiology Strategy, and he's backed up by Becky McCauley-Wrench, who's our program scientist for astrobiology. Sarah, sorry, I know it's a long slide, but if we could go back to it, I'd appreciate it. Thank you. Sarah Noble is our lunar science lead. Of course, you heard from her yesterday. Kurt Niebuhr is our lead scientist for flight programs. He also acts as our New Frontiers lead scientist, and Delia Santiago Matarese is our discovery program scientist. So some of those are a little bit different from last year. Also have not shown on here Tom Statler, who is our lead for small bodies. So now if we could go to the next slide, please. So this is the planetary fleet chart as it stands currently. And so for anyone who hasn't seen it before or has seen it and hasn't studied it in detail like me, the sun is in the middle, and we sort of go to the outer solar system as we go around the swooshes. The inner track is Moon and Mars. You can see we've got a tremendous amount going on there, including our CLIPS missions, of course, underway. And then the rest of the solar system is in the outer portion. So you can see for those missions, we start really in the asteroid belt right now and then go out to New Horizons, which is in the Kuiper belt. So there may be some changes here, but this is where we are right now. And you can see there's a tremendous breadth of science going on across the solar system. And just, again, just want to highlight the key here. So the green and blue icons are missions that are operating right now. They're either in their prime mission phase or their extended mission phase. And the orange and yellow are in formulation or implementation. If I could go to the next slide, please. Excuse me. Okay, so I'm just going to go through some of the highlights from across the division. So the first one is, sorry, you can go to the next slide. Sorry, it'd be so much easier if I could do it myself. Just want to highlight a really nice result recently that took place in April. And so this is the Lucy spacecraft. It's one of our discovery selections from the selections before the last ones. So Lucy is on its way to the Trojan asteroids at the Lagrange points around Jupiter, and it's actually going to fly by 7 Trojan asteroids, and a couple of them we think have moons, to look at these really primitive bodies from sort of early on in our solar system. But on the way, the Lucy team has found 2 targets they've been able to fly by. This is the second of them. It's called Donald Johanson, after the discoverer of our sort of oldest ancestor. We've now named Lucy, so this is an ancient skeleton. And this asteroid was an opportunity for the team to do a sort of full dress rehearsal before they arrive in at their first target in 2027. And so they were able to turn on all of the instruments on the spacecraft. And we knew as we were approaching this body that it had a very interesting light curve, but I don't think anyone could have predicted it would look like this. So it's a contact binary with a very interesting sort of helical structure around the contact point. So it's also a bit larger than we thought. It's about 5 miles by 2 miles. So really interesting result, and we're looking forward to just more to come over the next few years as we get into the Trojans. Next slide, please. Okay, so did want to say a few words about Psyche. So you may have heard that Psyche had an anomaly recently. So we are headed towards the asteroid Psyche, which we're going to encounter in August of 2029. And this is basically an ion propulsion system. It's using xenon as the fuel. And we detected a decrease in the fuel pressure a few months ago, actually in early April. And paused operation of the 4 electric thrusters to investigate. And so these are the thrusters that ionize and expel xenon gas, and that is powered by the two large solar arrays that you can see in the artist's impression here, these two sort of cross-shaped solar arrays. And we found after a lot of troubleshooting that there was a mechanical issue in one of the valves. This is a valve that opens and closes to manage the flow of that xenon propellant. And that created a decrease, so we weren't getting enough fuel into the system. Luckily, we had a couple of months before we needed to start thrusting again, and so we decided to move to the B side. So we've got a fully redundant system, actually maybe not fully redundant, but sufficiently redundant system here on Psyche so that we could transfer to the B side. We started thrusting back on schedule. We haven't lost any time at all. We are still on track towards our encounter with Psyche. We're doing a Mars gravity assist in the meantime, but everything's on course. And of course, this is why we design spacecraft to have redundant systems, so that in the unlikely event that something like this happens, that we're fully prepared. So Psyche is on its way. Everything's going really well. Next slide, please. Just want to say something about OSIRIS-REx. We had the first science publications from the sample analysis. That was back in January. And we just had another paper published in May detailing the petrography and petrology of selected particles from Bennu, and that was featured on the cover of Meteoritics. So very proud of that. The science analysis phase of the mission is going to continue until September 2026. We gave the team a little bit more time to do the analysis because of the delays with opening TAGSAM. Things like that. So stay tuned for more results. We were able to just tour the astrobiology lab at Goddard, actually, where they're doing some of the analysis, and there's some really exciting things coming back from there. And I think it really hammered home to me the importance of sample return, of actually having a sample in the lab. It's just such a different set of things that you can do. The sample catalogue is available online. If you want to go and have a look at it, just make sure you're signed up for the Astro Materials newsletter. That will keep you up to date on future calls for sample requests. And I did want to mention a couple of the team or members of the OREX team have been recipients of NASA agency awards. So this is a very big deal. Howard Connolly is the OREX mission sample scientist, and he's been awarded NASA's 24 Exceptional Public Achievement Medal. I don't know why it keeps going forward. Maybe I'm just being slow. In addition, I just want to congratulate the whole OREX curation team, because they've received a Group Achievement Award for exceptional perseverance in acquiring, curating and distributing Bennu astromaterials from NASA's first asteroid sample return mission. So congratulations to both of them. Thank you. Next slide, please. Okay, I want to say a few words about Europa Clipper. So Clipper, as you're probably aware, launched in October, picture perfect launch after a hurricane blew through. It was very exciting to be down there, but we're up and running. We've been testing out the instruments. Everything's going extremely well. We were able to fly by Mars in March as part of a gravity assist to get Clipper into the right trajectory for its encounter with Jupiter in 2030, or the Jupiter system rather. Not encountering Jupiter in 2030, that would be very bad, but we are going to orbit in the system. So Clipper actually flew about 550 miles above the surface of Mars, and there is a little video that I guess isn't, maybe will play, maybe won't. Anyway, it just shows you the sort of details of the encounter. But this was a wonderful opportunity to test two of the instruments in particular, all the components of our radar instrument for the first time. So it's got a very long wavelength. We weren't able to do a full test on the ground. So this is Reason, built at JPL. First indications show that it worked really well. We're getting the full data downlinked and analyzed. We were also able to calibrate our IR imaging instrument, eThemis. And eThemis is a sister instrument to the Themis instrument that has been in orbit around Mars for I don't even know how long, maybe 20 years now, on Mars Odyssey. And it's the same team and it's the same PI, I think. Phil Christensen is the Themis PI, and I think a younger Phil Christensen was the PI of Themis, or still is probably, around Mars. And so by capturing thermal images of Mars now, we're able to compare them from Themis with Themis and really understand how the Themis instrument is operating. So we'll be better prepared when we get to Europa. Once we get there, of course, we're going to conduct 49 close flybys and look to see if Europa holds the conditions suitable for life. Thank you. Okay. NEO-Surveyor, just wanted to say a few words about that. So next slide, please. So NEO-Surveyor is it's a big telescope that's being built. It's run out of the Planetary Division. This is in response to a congressional direction, actually in 2005 originally, to search for and characterize every asteroid or potentially hazardous body 140 meters or larger. Those are of a size that could do significant damage if they hit the Earth. And the mandate is to search for at least 2/3 of these in 5 years, and we think we're going to get to over 90% of these in 10 years once this instrument starts operating. So we just completed a critical design review in February. Went very well. We are currently underway doing testing in the lab, trying to bring the telescope down to the operating temperature and just make sure that the optics are all operating as expected. We've also selected a launch vehicle, SpaceX Falcon 9. That was in February. So right now, everything is on track. We are looking at a launch readiness date of no earlier than September of 2027, but things are looking very good for NEO-Surveyor. Next slide, please. Just want to say a few words about Dragonfly. This, of course, is our mission to explore Titan, which is a really carbon-rich, complex carbon-rich ocean world, and we're using a rotorcraft for the first time. So we are continuing maturation of the design, and the team just completed their key milestone, which is the mission critical design review. That was in April 25. You can see there's a lot of people contributing to the mission. We're at its most intense stage of development right now. And as part of finalizing the design, we've evolved the concept from 2-bladed rotors to 3-bladed rotors. And you can see one of them here with one of our lead engineers, Philippe Ruiz is the lead engineer of the rotors. So that's a design change, but everything's on track. And we've also selected a Falcon Heavy as the launch vehicle. Right now, it's still a very complex mission, no doubt about it, but it's hugely exciting, and the team's done an amazing job, and we are completely on track to reach a launch pad on time. So right now, we're looking at July 2028 launch readiness date. Next slide, please. Word about Mars. So just a couple of updates from the Mars exploration program. We recently shipped our MoMA mass spectrometer to ESA. So this is the Rosalind Franklin rover that ESA is flying, and we have contributions of the MoMA mass spectrometer. We are also supplying some braking engines and some radioisotope heating units, some RUs. And this is a really interesting mission that's going to drill, I think, 2 meters below the surface and look for signs of complex organics. So it's a very interesting mission. That's just been delivered. The instrument was delivered recently. We're also, with Curiosity, exploring these boxworks formations. So this is the top image here. These are areas with raised ridges that are in polygonal patterns on the surface of Mars. They're hypothesized to record ancient habitable environments sustained by groundwater. So there's a strategically planned campaign for this region that's likely to last a few months. The Perseverance rover has traveled over 21 miles now. It's collected 28 samples. Some of those have been cached, some are sort of left on the ground for later collection. And then on the bottom here, this is a new panorama from Mars Odyssey. So I guess 25 years that's been going. So that's the one with Themis on it. And this just shows one of Mars' biggest volcanoes, Arsia Mons, actually poking through a canopy of clouds just before dawn. And this is just a perspective of Mars that we haven't seen before. This is similar to what the astronauts see on the Earth when they look down from the International Space Station. Next slide, please. So obviously you've already talked a lot about the moon. I don't need to say much about it. And Sarah talked yesterday about many of the lunar activities going on in PSD, so I don't need to repeat those. But I do want to emphasize how excited we are with all the lunar science work being conducted around the agency in support of Artemis. And of course, we're continuing to work hand in hand with our SEO colleagues, with Joel and his team. We're all still on a high after the first fully successful CLIPS landing earlier this year, and we are certain there'll be many more to come in the future. And we also appreciate how important the steps are that we're taking now to get back to the moon that will help define the success of Artemis and also the future of our exploration efforts. So the lessons we're learning today and tomorrow are going to help us prepare for crewed trips to Mars. Of course, you're all very well aware of that. Next slide, please. I'm not going to say much about the budget. Just don't want to get ahead of our new acting administrator. So you can go to the next slide. Thank you. I will just say this, as you are, I hope, aware, we are currently operating under a full year continuing resolution in 2025, and that actually means we're operating to a 24 budget. We are 25 was the budget was affected by the Inflation Reduction Act. So that's where we're at right now. So we're continuing with the same funding that we had last year, which was at 24 levels. It's very confusing. I'm getting a crash course in this at the moment. And in 26, again, I'm sure you're very aware, the President's budget request was released at the end of May, and full details at this link. And we're currently working on planning for FY27 and beyond. So we have multiple budget scenarios being worked and budget issues being worked simultaneously. As I mentioned, I'm unable to comment right now on any impacts to missions, programs or funding levels at this time, but we do anticipate that the agency and SMD leadership will provide updates hopefully very soon. Okay, on to opportunities. Next slide, please. And I know I've got just about 3 minutes left. Future mission AOs, given the highly constrained budget environment and as communicated in previous meetings, we don't anticipate releasing the AO for New Frontiers 5 before 2026, currently looking at the fourth quarter. The priority remains to support confirmed and selected missions before we start new ones. We are following the budgetary rules provided in the decadal survey as closely as possible, especially considering the competed missions. We expect to release a community announcement with some major mission parameters ahead of the draft AO. And the draft AO will be released once we finalise the list of mission themes, right? So the CAPS report was delivered last year. I think you're all familiar with what's on the list. We have not had a chance to really think about whether that changes in the light of PBR 26, the President's budget. So that's all TBD, but we do have some time to work that out. And as we've also communicated previously, we don't anticipate solicitations for Discovery or Simplex in the next 2 years. Next slide, please. RNA, we were very happy to finally get ROSES 2025 out on July the 10th. As you will have seen, the number of programs in ROSES 25 is substantially reduced, but we are committed to supporting the community as much as we are able, even if it's not quite as much as we would like. There are a couple of Planetary programs released as TBD. That means that if we are able and the funding becomes available, we will release them. One of those was DALI, Development and Advancement of Lunar Instrumentation. The other one was FINEST program. The new Solar System Science, or SQ program, is an omnibus that's inclusive of pieces of numerous ROSES 24 program elements. So it encompasses much more than the previously planned Emerging World Solar System Workings and Solar System Observations merger. We ask that you read the program elements in their entirety. Please make sure you check program priorities and exclusions. They're not all the same, and contact your program scientist if you've got any questions. I will note that lunar science is listed as a priority for SQ, for Solar System Science, and proposals are particularly encouraged for the development of new analytical techniques for existing lab instrumentation that will push the limits of current technology. So please take a look at that. And Kathleen van der Kayden, our RNA lead, is going to be holding a ROSES rollout next week. It's July 29th at 12:30 Eastern Time to discuss all of the details of the solicitations. I've seen the slides. Hopefully all your questions will be asked in there or answered in there, but there is a QR code for a WebEx connection if you look at this QR code here. So you can submit and upvote questions in advance. We are not recording the town hall, but Kathleen will answer any questions that are put in there, and we will make sure they are posted. And the other thing I just want to note is, unfortunately, as Sarah mentioned yesterday, the survey can draft is on hold for at least a year. Just haven't got the budget to support it at the moment. So just my last, this slide, and then, sorry, the looking ahead slide, please. And then just one more. Sorry, next slide, please. Thank you. And then one more slide, please. Just want to finish by saying, you know, I know we are living in challenging times, but we still have an amazing amount of science that we can be proud of. There are several things on the horizon coming up, CLIPS landings next year and the coming year, and then 2 significant events for international missions on which we're partnered. One is the MMX mission to the Martian moons, Phobos and Deimos, by JAXA. They're actually bringing back a sample of Phobos. And we have an instrument on that mission. And then the joint ESA-JAXA Bepi-Colombo mission will also arrive in Mercury orbit towards the end of next year. So those 2 spacecraft are going to help answer many outstanding questions for Mercury and its space environment. I'm sure a lot of those are highly relevant to the moon. So just want to thank you for everything you're doing. Really appreciate all your efforts, and know it's a challenging time, but we've got a very strong community and a very strong program. We hope this will continue moving forward. So with that, I'm happy to take questions. I know I haven't left a lot of time, so I apologize for that. But please go ahead.
Thank you so much, Louise.
Oh, thank you.